This is the first video in a series about solving exponential and logarithmic equations. I'm just going to work through the examples and you can follow along as you need. For A, the easiest way to solve this is by recognizing that 64 can be written as an exponent with a base 2. So I can start by rewriting that. So I would have 2 to the x equals 2 to the 6th. I just happen to know that, but you could also look it up. This now allows me to use the one-to-one property, so I know that x is equal to 6. In example B, I can use the definition of a log. Recall that if we have log base 10 of x equals y, we're basically saying 10 to the y power equals x. 10 to the y power equals x. So here we could say 125 to the 2/3 power equals x. 125 to the 2/3 power equals x. Here we can use our knowledge of rational exponents. We know that this would change to a cube root of 125 squared. The cube root of 125 is 5, and 5 squared is 25. For example C, here again we can use the definition of logs. Recall that a natural log, that's an ln. The natural log is the same as log base e. So this is basically saying natural log of e, or natural log base e of x equals -2. So we can say e to the -2 power equals x. E to the -2 equals x. That is an exact answer. And if I'm being asked for exact answers, that's all you have to do. And finally, for example D, I can use the one-to-one property. Since this is e raised to a power equals e raised to another power, I can just take those two powers and set them equal to each other. -x squared equals -3x minus 4. I should recognize here that there is a quadratic, or this is going to be in a quadratic equation. So I'm going to start by setting everything equal to 0. So I add the x squared to both sides. And then I'm going to factor to solve. This factors into x minus 4, x plus 1, which means after I use my zero product property that x is either equal to 4 or x is equal to -1. And then I should go back to my calculator and double check that both of those are in fact solutions. And I can do that by plugging in 4 for x and on both sides and seeing if the statements do equal each other.